those people who are showing up late, they'll just miss some general announcements, but that's fine. So we're gonna be going over USACO review today. But first, can we go to the next slide? So first, there's some general announcements. So start off, we got some dates. So like our schedule. USACO, the US Open, the last one of this season, quote unquote, is April 2nd to April 5th. And that's also spring break. Spring break is like the first week of April, I believe. So we won't have a meeting that week. And we also uh, will have like the US Open that week. So it actually works out. So, you guys can like study for. Actually, it doesn't work out that well, I realized, because I think spring break starts on like Monday maybe, and that's when the US Open like is about to end. So that's unfortunate. But our last meeting is gonna be on the week after, the 14th. We're gonna be ending near mid-April, right? The 14th. Let everyone study for their APs, study for their finals, etc. And also USACO, like the season's over too. So that's pretty much about it. So the next couple weeks, we're probably gonna focus more towards USACO stuff just to study for US Open, but we'll also see we might do some other stuff. And also yearbooks, yearbook photos slash form. This is a general form that I'm sending in the chat right now. Basically, it's from publications. So uh yeah, it's not related to like any club in general, but it's related to all the clubs in general. So like when you're filling this out, you don't have to fill it out like with our club in mind, with any club in mind. And then if you weren't here for last week's pictures, then just send us a picture of yourself, preferably in like landscape. So like basically as if you were in like a Zoom meeting, right? Because like we're gonna like kind of Photoshop you into the Zoom picture. And obviously in the Zoom picture, uh everyone's picture is like more landscape, right? It's not like a portrait. So don't send us a portrait of yourself. Send us like a picture of you like kind of landscape and sitting. So you kind of fit in and like it kind of looks like you're in a Zoom meeting. And so just send us that. We forgot to include a date on the slides, but send us that preferably by Thursday night. So all of today and you have all of tomorrow. Send us like a picture of yourself, landscape, and sitting. And that's all we have for announcements. So I think Josh, you can continue on with the cycle review.
So we'll be looking over the US Open contest from 2020, so about a year ago. And this is the bronze division problem, so it's going to be a bit easier, I think. So
Oh
this is
wait, Josh, real quick, real quick. Sorry to interrupt, but for those of you who are on the officer team right now, can you guys private message me um what division you're in for USACO if you are participating? If like you haven't participated for just on like NA or something, just so we can get kind of more of like a scope of like a field of how the skill level of everyone else for the future. Yeah, that's it. Sorry.
AI. Cool. So this one is asking, um, to sum it up, what happens is there are um, a certain amount of cow. There's a 1D array. Imagine a 1D array of stalls, and cows can go inside each stall. It could be empty or it could have a cow in it. And now this farmer, he wants to bring in two more cows and put them into two vacant slots and have the maximum and have the distance between each cow, uh, or maximize the distance between each cow. So you want to maximize the distance between each cow even after introducing two new cows into the equation. So I'm gonna grab up a whiteboard. And we'll be discussing the problem with whiteboards. So we can imagine, let's bring up a theoretical situation where we have let's do 6 stalls. And there is already a cow in stall 2, and there's a cow, that's it, just one cow. Now you want to put in 2 cows and maximize the minimum distance between each cow. How would you do that? You put one cow here and one cow here. So the maximum distance between each cow, there's a one vacant spot between each cow. That's the maximum, or the minimum. Maximum or the minimum. Does that make sense? You want to maximize the distance between each cow so that the minimum distance between 2 cows is the greatest. How does making sense? Basically, if you put a cow here, then the minimum distance between each cow is 0. There's no stalls between. So that is obviously worse than putting the cow here, where the minimum distance is any one of these distances, which is 1 cow in the middle, or 1 vacant stall in the middle. You want to maximize the distance between each cow, basically. And now thinking about it, how would you figure out where to put the cows? Well, what you can do is you can start storing variables to count the number of vacant stalls between each cow. So for example, if we have a cow here and a cow here, the greatest gap is the middle. So you probably want to start putting cows into this vacant spot right here in the middle. And now there are, if we set up like, let me add another stall. If we set up like this and you want to add 2 cows, normally to maximize distance with 1 cow, you put them smack dab in the middle right here, right? And you get 2 stalls on either side. That's the minimum distance. That's good. But if you're putting 2 cows, you have to consider 2 different things. One is that you could either put 1 cow in the spot and maybe 1 cow somewhere else, like on the side or something like that. Or you could put 2 cows in this single slot or this single chain of vacant slots, in which case it will be better to not put a cow in the middle, but to separate the 2 cows and cut the space into thirds, basically. So there are 2 different ways to put cows. You gotta have 1 in this 1 vacant spot or 2 in this vacant spot area here. And so to start off, you want to count the chains of vacant slots that you have and store them into 2 variables. So one of them is long1. So this is the longest chain of vacant slots that you could put cows in, and maybe a second long. Or I guess you could put integers, but we're going to go with long for now. A second long number to store the second longest chain that you have. And another thing you want to keep note of is when you have cows on either end, obviously you want to stay as far away from the left side and as far away from the right side. So the best spot will be like in the middle, somewhere in the middle. But if let's say this is the beginning of the farmer's stall and we only have a single cow here, then the best spot to put a cow is not the middle, but instead the far left. So then you also want to store 2 variables for these edge case scenarios, which can happen at the beginning and also at the very end. If say, let's say just cow here, then this end slot, you will put at the end and not in the middle. So we store another 2, one for the beginning chain and 1 for the ending chain. And now you have 4 vacant places to put all of your cows in, with long 1 being the longest, and then beginning and end also having some chain to them, and long 2 probably being the shortest, or the second short, or the second longest, or the shortest. But basically, what you want to check first, you want to check long 1, beginning and end. You want to use these 3 chains that you found and try to figure out whether you want to put 1 cow into those spaces or 2 cows into those spaces. And you can do that pretty easily by just comparing long 1 to beginning and end. So for long 1, if you want to put 2 cows in, then what you're looking at is you have to divide your space into 3 segments and leave out. Wait. You want to divide your segment area into 3 different segments to put 2 cows in between. This is confusing. So like, if this was our long 1, if this was the longest chains of vacant stall, you want to take these 5 spaces and you want to take out the 2 cows that's already in there and then divide by 3. So 5 minus the 2 cows you're going to put in equals 3. You take that divided by 3, since inserting 2 positions will create 3 gaps, and that gives you 1. So it tells you that the maximum distance, if you put in 2 cows, is to have 1 vacant stall between each cow. So for long 1, the formula for inserting 2 cows would be the length minus 2 and then divided by 3. And beginning and end, if you want to put in 2 cows, it's a bit easier, since you want to put 1 on the edge and then 1 in the middle. Since when you're doing beginning or end, one side will be vacant instead of being filled in. So then it would be x minus the 2 cows that you're going to put in, and then divide into 2 separate groups of vacant slots. And that will be your number for both beginning and for end. You compare these numbers, and then you do the same thing for long 2. And you compare all these numbers, you're trying to find the best way to fit 2 cows into 1 slot. That's scenario 1. Scenario 2 is when you put 1 cow in 2 different chains of vacant slots. And for that, it's pretty much similar. You compare all these numbers, and then you also, but instead you use x minus 1 divided by 2. So you put in 1 cows, you split the area in 2. So for example, if take out these lines, if it's like this, then we have 5 vacant slots. We put in 1 cow, so there's only 4 vacant slots, and divide by 2, you can have 2 vacant slots on either side of the cow. So maximum distance is 2. So it's x minus 1 over 2. And for beginning and end, it's even easier. It's just simply x minus 1. Because if you think about it, whatever slot, how many slots you have at the beginning or the end, the best spot is just to put at the very, very end. So the amount of vacant spots available is just the total amount of slots minus the 1 cow that you put in. It equals the amount of slots between. So that's x minus 1. Now you just compare all of these numbers together, and you try to find the best scenario to put in 2 cows. So the 2 biggest numbers you get. And with that, I have you can see this one right here. This is the implementation of that. I think it's in Python. So you have the variables set up, long 1, long 2 for the 2 greatest chains. You have beginning and end to store the beginning and the ending thing. And these ones are just counters for actually parsing the information into those different chains. And down here, this is where you will start going through them. So when they provide you, they give you either 0 or 1 for vacant or fill, or has a cow, whether it's vacant or it has a cow in it. And if it's 0, it means it's vacant. You can increase temp. So temp will be storing what is the current chain that we're on, the current number of vacant stalls in a row that we're currently on or reading through the data. And that will be temp. We store temp at the beginning the one time for the very beginning. And then after that, you will don't restore in beginning again. And at the very end, you also store whatever temp is into end because that is your ending chain. That's the very last chain. And long 1 and long 2, you just basically compare temp against long 1 and long 2 and it's checking to see whether they surpass it or not. If it does surpass long 1, then long 1 will go into long 2 and long 2 will just be deleted since you kind of shift them all down by 1 step. After that, you just implement some check methods. You check the maximum between, these are the putting 2 cows into 1 slot. And down here is putting 1 cow into 2 separate slots. And then you just check which one has the better, which one's more efficient, and then you print it out. So that is the first problem. It's a bit confusing and it's kind of a bit algorithmic. Oh, God. Yeah, for question 2, this is like continuation. It even says social distancing 2. Now, what's happening here is that they want, it says that farmer John is worried for his cows, and he has an N cows and practice social distancing. And some of them still, or many of them will contract the disease. And then he knows that there's a radius R that any cow within R units of an infected cow will become infected and pass that infection on and on. He doesn't know R, but he does know which cows are infected. Then you want to determine the minimum number of cows. As for that, we're a bit short on time, so I'll skip the general picture explanation for now and skip to the code. So over here, we have an array. The array will store the cows are infected or not infected, and we'll move on. Line in lines, that will just basically parse through each line to give us. So if you remember, I forgot to mention this, but right now, if you're taking a competition recently, you know they use like, they give it to you in input and then you print it out, like you literally print it out. But before you have to write it into files and read from a file. So that's what these beginning things are for and the line in lines. So that's just reading from a file. And then from that, you just check whether it's 0 or 1 and then you append it. Oh, I mean, sorry, not that. This is actually a very stupid implementation. Don't worry about that. What that does is just parse out the very first number. So when they give it to you, the very first line is actually the number of cows there are on the farm. And that's just to separate the number of cows from the other data. And the other data will give you 2 numbers. The first number is the position of the cow. The second number is whether it's infected or not. Infected is like 1, I believe, and 0 is healthy. And then after that, this is just a sort method. I kind of switched up how to sort. And why you would need to sort is because when they give you the cows, the positions aren't in numerical order. They give you like cow number 7, then cow number 1, and cow number 15. And if you sort them, it's a bit easier to run through them in a linear array. And after that, we just start. Distance is set to a very big number. It's probably advisable to actually use math.max integer or something like that to get the actual true maximum number. But for now, I just put in this number since in the problem it does limit the number of cows or the number of cows there are. So that is like the max or the size of the array. So then you're just limiting to the max. After that, you just count through each one. You check whether it switches between infected or uninfected, and then you try to determine the minimum the minimum distance. So you check between distance and then the time between or the distance between each infected cow, and the minimum number would be the minimum distance required to infect every cow, or the maximum. Now I'll pass it over to.
Okay, so I'll be talking about the third USACO problem. So this one is not a continuation of the last one. It's like totally different. Um, so if you read through this, basically what this problem is asking you to do is um, it wants you to find the cows that is like the zero patient. So this problem, it starts out by saying that the cows, when they greet each other, they will basically like shake hooves and then they will infect each other. And then they give you like a timestamp of list of all of the interactions between the cows. And then using that, you can basically find the zero patient. Okay, so the input and output, I think this is the more important part. Input, they first give you n and t. N is the length of the number of cows. So this is the end result of cows, basically. So in this case, that is 1100, and 0 means healthy, 1 means infected. So this means it will be infected, infected, and healthy, healthy. And then the next number that is on the first line, that is T, it tells you how many lines of records there are. So in this case, there's 3 records of these interactions. And each of these, there's 3 numbers. They call it T, X, and Y. And the following is like this. T is the time of the interaction. So uh, obviously, they don't give us it in order, but we can just sort it. And then X and Y are which cows shook hands. Okay, so we're gonna try to work through the sample input and see how they get this. So 4 and 3, we notice that um, the first 2 cows are infected, but the rest 2 are not. So what that basically tells us is that this 2 and 3 interaction and 2 and 4 interaction both happened when 2 was not infected. And it shows that because 5 and 6 are before the 7. So basically what that means is 2 cannot be the first 0 patient. So the only option is 1. So they want us to print out the possible 0 patient. So that's going to be 1. That's our first output to print out. And then the second one is K, which is how many times they could have shook hooves. And then obviously the lowest number for that is 1, because they do have to shake hooves 1 time. Otherwise it won't work. But there's no upper bound to the shaking hooves in this case, because um, we can just imagine this. Uh, Let me turn on this. So we start out with, we've already established that 2 cannot be the first patient. So we know 1 is the first patient. I'm just going to shade it to show that it's like infected. this will happen first because it's 5. So 2 and 3 will shake hands first, and nothing really changes because none of them are infected. And then the next one is this 2 and 4. So this one and this one, also nothing changes because neither of them are infected. And then the last one is this 7, and then this is where 1 and 2 will shake hands. And this is how we end up with uh, these being infected like this. And notice how it doesn't really matter how many times they shake hooves or shake hands. It's still gonna be the same result. So that's why there's no upper bound and it can be infinity. Okay. So that's basically the preface of the problem, and then we're gonna look at how to approach solving it. So this is the analysis. This is I think this answer code does work, but it's in like C++ or JavaScript, and I'm not too familiar with that. But basically, you can brute force this problem since it's not the data isn't too big, and you could just try every number for the 0 patient. And that's what they did in this case. So just try all the possible combinations of which cow is patient 0, and then we try the value of k. So the possible things that we have to try each 0 patient and then each k value k. So that's why the total runtime is going to be this, and that's about 6.5 million steps, and that's fine because that is within the threshold of whatever USACO gives you for the runtime. So that's why we can just use brute force for this. Okay, I'm gonna reshare this so I could show the code. Okay, so this is the code in Python. Thank you for Joshua for giving me this. But first we're going to read the file that they give us. In this case, I don't have the file downloaded. So I'm not gonna do that. But basically, the file, it's like this for all USACO competitions. It's just like a file of all the data, and then you have to run it. And then usually you run it in like your own Python editor. So I'm using PyCharm in this example. And then if everything works, then you upload it. The process might be a little bit different because I'm not too familiar with that. But this sort is the one that is what I talked about. It's going to sort all of the uh, values according to their timestamps. And then once we do that, it's really not too difficult. We can just spam a bunch of for loops to brute force. So in this case, there's like 3 sets of for loops. And it just basically just tries every cow for its 0 patient, and it tries every k value. And remember the analysis, it said that it won't take like too long. So that's why this is a viable solution. Okay, and then remember that you have to print that like infinity thing if it exceeds. Okay, that's about it for this part, for this problem.
Are we done? Josh Lucas.
Yep,
Yeah.
that's all we have for today.
All right, so I guess we can head out. We have 10 more minutes technically. Uh, does anyone have? Yeah, sure, Josh. You wanna go with it? Yeah. Wait, what do you mean? Hmm. Okay, so let's do like a poll. with the people who are here. So options. So would you guys rather do a rock paper scissors project starting next week, or continue USACO? And for the rock paper scissors project, Josh, do you want to give like some more info right now?
Alright, so for those of you that took
Mhm.
computer science essentials, you probably remember that you had to make a rock paper scissors bot in Python that plays against another bot, and you can implement different methods to try to make your bot smarter. You can have like machine learning, or you could just like throw a rock every single time or something like that. But basically, what you'll be doing in this project is you'll be making a bot that will play against another bot for like several like 100 rounds or so, and your bot will want to take in inputs like we'll make a system that will give your bot results from the previous game that it played, and from that you can try to make your bot learn as it plays and try to adapt to different scenarios. And what we'll have is at the end of the project we'll have all of your bots, all of your rock paper scissors bots play against each other and see which bot is the best rock paper scissors player. Yeah.
Right. And then for the other option, which is continue Sakura review, is basically what we did like today, except probably with some different problems, etc. So I don't have the poll option on Zoom. I know some of them do. I think that's like not the free Zoom. So can you guys like message me like one or two, or just message me USACO or rock paper scissors, and so we can kind of tally it up. If we get like a tie or like yeah, if we get a tie, uh we'll figure out later. Yeah, we'll figure something out if we get a tie. All right, so if you already messaged me, I guess you guys can head out. Otherwise, I'll end the meeting in like 1 or 2 minutes. I'm gonna end the meeting.